All right, so we're going to start on page 28 in your notes packet. So if you would take a minute, open up to page 28. And if you look here, we're going to be talking about odd and even functions. Now you did this last year in Algebra 2. There's a couple things you need to remember about each of these. So we have an even function. That's what we're starting with right here. An even function. And the things that you need to know is that it's symmetrical to the y-axis. And you also need to know this rule here in the box. Okay? All right, and I'll go over that in just a second. Now, then we have an odd function. And an odd function is symmetrical to the origin. I'll go over that in a minute. And here is the rule for an odd function. So you should highlight those, or maybe you should circle them, you should star them, something to that effect. All right, an even function. So here's an even function. It's symmetrical to the y-axis. All that really means is if I were to fold my paper along this y-axis here, this left part here will match up perfectly to the right part. Or you can go vice versa. The right part would match up to the left. So when you fold, this is kind of like a flip-flop, okay? And it flips over right onto the other side. Okay, that's what symmetrical to the y-axis means. Now that would be in the case of if you had a picture and you can look and visually see. Okay, if you don't have a picture, then we're going to use this rule, which we'll deal with in a couple of minutes. Again, this is all review, though, of Algebra 2. All right, now let's go to the odd function. Symmetrical to the origin. I like to write it this way. Oops, maybe I should get my pen and then we can write it that way. Would you do me a favor and right above that, write up, side, down. So basically what I mean by that is if you take this picture, and you guys can do this, you have your packet, turn your packet upside down. Okay, do it. Turn your packet right now upside down. If you do that, look at your picture, and it should really look exactly the same as this one. So when you turn a picture upside down, you can turn it right side up now, by the way. When you turn a picture upside down, if it's the same picture upside down as it is right side up, then it's what we call an odd function. Okay, and here's the rule for odd, but again, we're going to use this when we don't have a picture. So right now, we're just going to be looking at the upside down and flipping over the y-axis, okay? All right, so what I'd like you to do is turn to page 29. And let's look at these 6 problems. I want you to pause me for a minute in a second, all right? And I just want you to look and eyeball these pictures and determine, now please read very carefully, some of the functions may be even, some may be odd, and some of them might not be either. Okay, so you're going to write even, odd, or neither on each one of these. Okay, pause me, work them out, check with the people next to you, and then turn me back on so you can see whether you got it right or not. Okay, so here are the answers. So just be careful. I had some kids that were making mistakes with this one. This is neither. I can't flip it over the y-axis because this piece right here, it's not over in this direction. And this piece over here should really be over here. And when I turn this upside down, I want you to look at where the y-intercept is. It's below the x-axis. But if you turn your paper upside down, this point here is now above the x-axis. So this is a neither. Hopefully you'll see that these guys are even. Odd, turn your papers upside down, and you'll see that these look the same upside down as they do right side up. And this is a neither. Okay? All right, so that's basically what you do when you have a picture. Now, if you look at the bottom of page 29, we don't have pictures. And we could probably sketch these pictures out and figure out what they are, but sometimes you're going to get equations rather, that you have really no idea what the picture looks like. So we have to actually come up with the algebraic way of doing it. Okay, so I like to start with determining the even. Okay, so the even rule, and I'm just going to put, oops, I always keep thinking my pen is on it. It's not. I'm just going to put E for even. Okay, so my even rule, remember, is the original function f of x equals f of negative x, okay? Now, if you remember from last year, what that basically means is you're going to take your f equation right here, and everywhere you see an x, you're going to replace it with negative x. So I see an x here, I'm going to replace that with negative x. I'm not changing the 3, and I'm not changing the squared, okay? So when you're doing f of negative x, I keep the 3, I'm just changing that x to negative x, and then I'm squaring it. Okay, let's do the same thing for 8. We're on a roll here. So f of negative x, same deal again. I'm going to change the x to a negative x, but I'm keeping the cubed, and I'm keeping the minus 2. Okay, and let's keep going with number 9. So f of x, f of, I'm going to squeeze in a negative there. That's a negative x equals, keep the 3, put in a negative x, and then add the 4 at the end. Okay, all right, let me just, so we don't run one into the other here. So now I'm going to simplify a little bit here. So let's do f of negative x. Okay, so what is a negative x times a negative x, right? Because isn't that what squared means? Negative x times itself. So negative x times a negative x. Isn't that a positive x squared? With the 3 in front, of course. So that's 3x squared. Okay, now this is why I like to do the even rule first, because it's the shortest. Because they already gave you the f of x, that was the original problem. Okay, so that's this part right here. There's your f of x. And now we want to see if it's equal to f of negative x, which is this one down here. And look at them. They are the same. Okay, now you must, I repeat, must write it in the following manner. And you should be taking notes in your packet. You are always going to restate the rule. So f of x, in this case, equals f of negative x. Okay, now I use the symbol for therefore. It's 3 dots in like a triangle. You can write the word therefore if you want. I just don't feel like it. It's too long. So f of x equals f of negative x. Therefore, it is even. And there is your answer. All right? Okay, let's do the same thing with number 8. So I'm going to just rewrite this, f of negative x. Now, let's be a little careful with this one. It's not hard, but we're doing negative x times negative x times negative x because we've got 3 of them, right? So what's a negative times a negative times a negative? And hopefully you realize that that is a negative. So this is going to be negative x, but it's going to be cubed, right? Minus 2. Okay, now if I'm going to follow the even rule, these 2 are the ones that are supposed to be the same. Do you see that's not the case? Okay, those are not the same. One of them is a positive x cubed and the other one's a negative x cubed. You have to restate the rule, but we're going to make a small change. So what I'm going to do is I'm going to write f of x does not equal f of negative x. And then I'm just going to put the therefore symbol. Instead of writing even, because it's not, we're going to write not even. Okay. Now, if it's not even, we have to test for odd. So let me go back up here. My odd rule, I'm going to just write O for odd, is negative f of x equals f of negative x. All right, so I'm going to talk about this in just a minute. That's easy enough. But this right here is already down here. It's right here. You do not need to redo work that you've already done. We just need to know that we're going to be comparing this to negative f of x. And all this means is negate your original function. I'll repeat it, negate your original function. Here's your original function. Negate it is very simple. Change the signs. That's it. Okay? All right, so here we go. So I'm going to write negative f of x, and all I do is change the signs. So that x cubed becomes a negative x cubed, and that negative 2 becomes a positive 2. All right, so there's negative f of x. Now, what we have to do is we want to group it with the negative f I'm sorry, f of negative x, these two right here, okay? Why? Because that's the rule. Negative f of x, that's this. F of negative x, that's this from the last part. Now look at them. Those are not the same. Okay, so similarly to what we just did on the top part, we're going to restate the rule always. You will not get full credit if you don't restate that rule. So you're going to write negative f of x does not equal f of negative x. So therefore, not odd. Now, if something's not even and it's not odd, then your final answer then would be a neither. And you do have to write that word. You can't just write not even and not odd. You have to write the word. Okay? All right, let's look at number 9. So I'm going to start with f of negative x. And, oh, actually, we already have that. So why don't we just simplify that? Okay, so 3 times negative x is negative 3x plus 4. Okay, and then I'm going to group, because remember what the even rule is. It's up there at the top of the page. I'm just going to group, you know what, let me do this in blue, so just in case it runs into number 8 here. So here is my original function, boop, boop, and there is my f of negative x. If I compare those are not the same. Okay, so this is not going to be even, but we need to restate that even rule. So we're going to write f of x does not equal f of negative x, and therefore not even. All right, let's go look at the odd rule. Well, we already did this part. Okay, that's right here, second step down. So we just have to do this. Remember, negate the original function. Here's the original function, and all we're going to do is we're going to negate that. Okay, so negative f of x, let's negate that original function. So that's going to be a negative 3x, make that look like a negative, and then we're going to have a minus 4 instead of a plus 4. All right, so let's connect the two. So I'm looking at this one right here, and sorry, it's all squishy and gross, and that one right there, and you can see those are not the same, just like number 8. So we're pretty much going to follow that same pattern. Okay, so we're going to write negative f of x does not equal f of negative x, and then you're going to write therefore not odd, and then you're going to write the last important bit of information, which is this is a neither. All right, so turn the page, look at page 30, and go to number 11, and I want you to do that one by yourself. Just figure out whether it's odd, even, or neither. I see that, I mean, you should see that number 14 is right here. We're going to do that one together. I just want you doing 11, so pause me and go ahead and do it. Okay, there's your answer for number 11. Pause me if you need to write anything down or check it. Otherwise, I'm going to go on to number 14. Okay. Please, again, make sure you are taking notes in your notes packet. Okay, so number 14, we're still going to do the same thing. It's just a little bit different with the fraction, but it's not a huge issue. So let's start with the same thing again, where we're going to put a negative x everywhere we see an x. So I see 3x squared, so I'm going to make that 3. Negative x, that quantity squared, plus 8. Okay, and then in the denominator, I'm going to put negative x. I'm going to cube that, minus 2. Okay, I have the room, so I'm going to work my way over this way. Now, if I negate an x and square that, that's going to be positive 3x squared plus 8. And if I do down here, if I do negative x times negative x times negative x, because there's 3 of them, right? That's going to be negative x cubed. So negative x cubed minus 2. Okay, compare these two, and I think you can see for yourself that those don't match. The denominators don't match. So I'm going to try to squeeze it in here. So I'm going to write f of x is not equal to f of negative x. Okay, therefore not even, right? I don't think that that's really all that tricky. And I hate to even use the word tricky because I don't think that this is tricky. I just think it's different. Okay, so here we go. So now we're going to try the odd rule, right? Now remember, the odd rule is going to compare this to the negative f of x. So this is the only part you just have to be a little careful of. A negative f of x means that you are going to negate the original function. So here's the original function. Guys, when you negate a fraction, you just have to be careful. You can't negate the top and the bottom. Think about it. If I had, making this up, 1/5, and I negate the top and the bottom, the numerator and the denominator, I get -1 over -5. Well, not for anything. Isn't that the same thing? Okay, because when you have a negative over a negative, it's still a positive. So you really haven't negated anything if you go from this to this. So when you are negating a fraction, you have a choice. You can either negate the numerator, but then you'd have to leave this a regular 5, or you can negate the denominator and make that a -5, but then you have to leave this a regular 1. Okay, so when you are negating fractions, pick one. It doesn't matter which one you pick. Pick the numerator or the denominator. I'm going to show you both just so you kind of get a comparison. So let's say I choose to negate the numerator. So that would give me -3x squared minus 8. Now if I do that, I can't touch the denominator. So that's just x3 minus 2. X cubed, I'm so sorry, minus 2. Now, I'm supposed to be comparing this to this. Do you see that these are not the same? Okay, so it's not going to be odd. But let's hold that off for just 1 second, because remember, the other option would be to have left the numerator alone, 3x squared plus 8, and change the denominator, which would be -x cubed plus 2. We were so close, because look, compare this and compare this. They're almost the same, but darn it, that's a +2 and that's a -2. So do you see, whether you negate the numerator or the denominator, this is still not an odd function. Okay, so then you're looking at these two and comparing them, and I'm just going to write it down here in red because I can't fit it. So let's restate that rule. F of -x does not equal -f of x. Therefore, whoopsie, therefore not odd, which then means we've got another neither, and that would be your answer. Okay, so that's how you handle it when you have a fraction. Again, not hard. You just, again, need to remember, and if you want to write this down, write this down. When you're negating the original function and it's a fraction, either change the numerator or the denominator, not both. All right, so now I want you to turn the page to page 31, and here we go, all you visual learners, you're going to like this. So what we want to do is, it's saying to complete the left half of the graph. So in other words, there's going to be a graph over here somewhere, but we want to make sure it's even. So remember, if something is even, if we fold along this y-axis, this right part here has to match up over here. Okay, so what I'm going to do is I'm going to work in a different color just so you can see it. Obviously, the origin stays the origin. So what I do is I go over to the next important point, which would be this one right up here. And I see that that's at 1, 3. If that's reflected over the y-axis, that's going to be this point right here, -1, +3. So I'm going to put a dot right there. And if you want to connect as you go, that's fine. If you want to wait, that's fine. Okay. All right, so then I'm going to go to the next important point. So here I am up at this peak here. And now if I look, I've got this point 4, 1. Well, over here, that's going to be -4, 1, this point right here. So I'm going to put a dot there at -4, 1. And then I'm going to connect these guys. Can you see it forming now? All right, last one. Then I'm all the way down here. I'm going to go all the way up, and I believe that is 6 comma, I can't count. 1, 2, 3, 4, 5. So this is 6 comma 5. So I'm going to go out to negative 6 comma 5. So right up here, you're going to put a dot. Okay, right there. And then we connect. Isn't that cool? And look at that. Now you've got an even function. Okay, because this left part, when I fold it over the y-axis, is going to match up. Pretty neat, right? All right, make sure you're writing this down. Okay, so now, same graph as what we had in part A, but now we want to determine whether it's odd. Now remember, odd is the opposite. So, well, listen, this is going to stay this because it's at the origin. Okay, so now I'm going to do the first point with you, and then you're going to do the other two and see if you can figure it out. So I go over 1, up 3. So what I'm going to do is I'm going to go over 1 to the left, and I'm going to go down 3. So we're going in the opposite direction. So I'm going to say that again. Right 1, up 3. So I'm going to go left 1, down 3. And I'm going to put a dot right there. Okay, so there we go. So you're going in the complete opposite direction. All right, now you are going to then graph the rest of this. So pause me, graph it, check with the people around you, then turn everything back on and check with me, okay? Okay, and there's what your picture should look like. Okay, flip the page and go to page 32. And we are going to just, how about we look at number 24 up there at the top? So I want you to do A, B, C, and D. Pause me right now. Work on them, work with the person next to you, see what you get, and then turn the video back on and you can check your work. Okay, there are your answers for part A and part C. Okay, you don't have to be Picasso, but you need to have the general behavior of the graph. So there's A and C, and now I'm going to do B and D. Please make sure you are graphing these in your notes packet. Don't leave this stuff blank. Okay, and there we go for B and D. I know I'm a little bent backwards over here. I'm sorry. My marker doesn't work as well as your pencil probably does. Okay, so there's B and D. All right, then the last thing I want you to do is, just for the extra practice, I want you to do at the bottom of page 32, number 1 and 2. Okay, you're going to work out those using the rules. Okay, f of x equals f of negative x for even, and negative f of x for f of negative x for odd. Pause me, work those out, come back, and you can check your answers. Okay, so the bottom of page 2, you're going to be working on these two. Pause me. All right, there is your answer for number 1. If you need to pause to write this stuff down or check your work, just pause the video and go ahead and write it down. Alrighty, and there is your answer for number 2 at the bottom of page 32. Okay, so at this point, if you need to pause me to write that down or fix anything, go ahead and do that, and then unpause the video. And I'm not going to begin to even read you what your homework is, so go on to Google Classroom, look at the assignment calendar for September 13th, and you will see it there. There's some random numbers there, okay? From page 30 and from page 33. All of what we just did just worked out a little bit, more and for you to work on by yourself, and we will check answers tomorrow.